Hello everyone, welcome to Alchemistry. So taking few of the question from all the syllabuses, and I have taken the questions from the whole syllabuses because if you solve the question, if you go through the question, and I have followed exactly the specimen copy that format, and if you go one by one, then you can understand which chapter you have to study more, which chapter you are weak, and which chapter you are strong, and like this way you can do your revision. So that's why I'm covering all the chapters of the syllabus of semester 2, and we will discuss some questions. This one is part 1 video, and I will publish part 2 video also. And to get the answers in PDF form and for more books, you definitely join my Telegram channel. There I will share everything, every possible notes, books, and the solved copies. And so without wasting any time, let's get started. So the first question, as you can see here, is some filling the blanks are there. So in the fill in the blanks, I have taken like the specimen copy. The first question from chemical kinetics. So this one is from chemical kinetics. The question is given is when the concentration of a reactant of first order reaction is tripled. That means if we consider the first order reaction, so let's see. When the concentration of a reactant of first order reaction is tripled, the rate of the reaction becomes dash times. That means first order reaction, so we can write it like rate equals to rate constant into reactant concentration. This one is the reactant, and as the rate is first order, so reactant to the power 1 for first order reaction. Here the concentration got triple, thrice of the initial amount. If it was rate 1, it was reactant 1. Now rate 2 equals to K, 3 times of reactant 1, that is reactant 1. That means rate will also become 3 times. So the rate will become 3 times. So let's see where is 3 times. So it will be the first blank will be filled by 3. The unit of rate constant for zero order reaction. For zero order reaction, as we all know, that rate equals to rate constant reactant to the power 0. So the unit of the rate will be unit of the rate constant for zero order, that is mole per liter second inverse. Okay, so this one is the first question. Then coming to the next, the transition metal sometimes show dash character. So what we know, transition metals show paramagnetic as well as diamagnetic character depending upon the number of electron present, and because the absence of unpaired electron. So when unpaired electron is absent, that means it will show the diamagnetic character. Diamagnetic. So here the first blank will be filled up by diamagnetic. Then we are having why V3 plus is dash, because its electronic configuration is argon 3d2. 3d2 means if we see the 3d orbital here, 1, 2, 3, 4, 5 subshell is there, and 2 electrons are present. So 2 unpaired electron present. So V3 plus will be paramagnetic in nature. Paramagnetic in nature. Then we are having primary alcohol or controlled oxidation gives dash, but secondary alcohol gives dash. So if we go for primary alcohol having the formula, suppose RCH2OH, this one is the primary alcohol we can consider, and secondary alcohol we can consider as RCHOH, secondary alcohol. So if we go for the, if we convert them, if we add any oxidizing agent, if we see they will go through oxidation, then by oxidation of alcohol we can get aldehyde or ketone, then by oxidation of aldehyde or ketone we can get the acid. So let's see what will happen here. Here two hydrogen already present, so by oxidation here one double bonded O will form, and to make one double bonded O, one hydrogen and one hydrogen from oxygen, one hydrogen from carbon will go out. That's why it will become the oxidation, and one hydrogen will be there. But in case of secondary alcohol, to oxidize it, one hydrogen from carbon, one hydrogen from oxygen will go out, and here no hydrogen remains with carbon. That's why the first one aldehyde will form, and the second one ketone will form. So here if we go for this, primary alcohol on controlled oxidation gives aldehyde but secondary alcohol gives ketone. But if it would not be retained, controlled oxidation, that time both of them will give you the acid. It will not stop at aldehyde or ketone. Okay, let's go to the next question. The type of hybridization involved in square planar. Whenever we are having the square planar type of complex, that means suppose this one is the metal and ligands, four ligands should be there, because in the square planar complex always four ligands should be there, and other can be electron, or can there will be absence of can be absence of lone pair also. So in square planar complex, coordination number equals to 4, and as we know from coordination chemistry, coordination number 4 means two possible structures are there, tetrahedral and square planar. So if tetrahedral, it will be sp3 hybridized. If square planar, it will be dsp2 hybridized. So here option will be dsp2 for square planar complex. Okay. Going for the next question. 1 mole of symmetrical alkene on ozonolysis gives 2 moles of acetaldehyde and the alkene is. The best way to solve this question is, first of all, take the general formula of the alkene. This one, and they are giving you acetaldehyde, that means aldehyde. So take one hydrogen with the carbon. Now add the ozonolysis reagent. That one is zinc, H2O at second step. In the first step, O3 ozone. So here it will divide it into two parts and get attached with double bonded O. This is the rule how we will see ozonolysis. As this one is symmetrical alkene, not asymmetrical, that's why it is giving 2 moles of same aldehyde, and that one is called acetaldehyde. That means, by the formula of acetaldehyde, this is CH3 CH double bonded O, so that R will be CH3. So if we put CH3 in the place of R, then formation of acetaldehyde is possible by 2-butene. See the next question. Acetamide reacts with bromine sodium hydroxide. So our preliminary compound is acetamide, CH3CO NH2. It will react with Br2 NaOH. First of all, you have to identify the reagent is for which reaction, and here amide is present, and amide can go through a various reaction, among which one of the reaction is Hoffman bromide degradation. So if we go for Hoffman bromide degradation, it will convert into primary amine CH3NH2. So here acetamide reacts with bromine NaOH and will give methylamine. So here option A will be the correct option. Our next question is, name the type of isomerism shown by each of the following pairs of compound. So we have to select the isomerism here. First of all, if we want to identify the isomerism, you have to go to my coordination chemistry video also. My coordination chemistry video, there also you can find the things, the isomerism things. So structural, geometrical, then again geometrical, there is optical, again we will get, and under the structural, ionization, hydrogen, etc. Okay, so here we are having platinum dichloro platinum tetramine dichlorobromide and platinum tetramine dibromochloride. So here the basic difference, if we ionize, here chlorine we will get as ion, but here bromine we will get as ion, whether chlorine is added inside in the coordination sphere and here bromine is added in the coordination sphere. So they are actually ionization isomer. So if we want to identify, these are ionization isomer. Then we are having cis and trans. When clearly cis and trans is written, that they will be under geometrical isomer. Geometrical isomer. And if there will be two mirror image of cis, then that will be optical isomer. Okay. So next. Okay, write chemical equations to illustrate each of the following. So as I've told you, name reactions are very important. That's why I've taken this question. So name reaction, if you go for aldol reaction, this is a very important reaction. This is a very important reaction under that carbonyl groups. So aldol reaction. If you go for aldol reaction, here the thing will be, suppose we are having one carbonyl group that can be aldehyde, that can be ketone, but that should have at least one alpha hydrogen to go through the aldol reaction. And another also I am taking the same aldehyde or the different ketone. So if I want to illustrate with respect to that equation, so first what will happen, sodium hydroxide is present in the medium, the base. So sodium hydroxide will capture one of the hydrogen and it will make the negative charge. Once a negative charge has came, now this as this carbon was acidic in nature, now this carbon and this carbonyl group can react and they can make the bond. And if they will make the bond, then we will get like this type of thing. Here OH will be here to CH3, and that CH2 group is attached to another aldehyde. And the next step, this dehydration may happen. This hydrogen, one hydrogen can go out, and from here OH may go out and double bond may happen here. So this will be the aldol reaction. Basically here aldol, OH we are getting, and aldehyde also, the carbonyl group also present. So this one will be the aldol reaction. Okay, next coming about the carbylamine reaction. In case of carbylamine reaction, we should have one amine first of all. Then with that amine, in the basic medium, chloroform will react CHCl3. Then this amine will be converted into methyl. If we have taken methylamine, then it will be converted into methyl isocyanate. Or if we will take any other amine, it will be converted into isocyanate. Isocyanate. So for any reaction, for explaining any reaction, when you are writing in word, you need the starting material, the reagent, the ultimate product. And when we will explain by word, of course you have to give one example, the equation you have to give one. This is the question and answer. Okay, here the necessary reagents of conversion are asked. So aniline to chlorobenzene we are getting. First of all, let's see what are the structures of aniline and chlorobenzene and what are the functional group conversion happening. So we are having aniline here. And we will go towards chlorobenzene. So let's write chlorobenzene here. Whenever from aniline to any group conversion is given, try to go through that diazonium salt formation. That is the easiest pathway. So if we add diluted HCl 0 to 5 degree centigrade temperature, and along with and we need the NaNO2 for the source of NO positive electrophile. So we will get the diazonium salt here into positive. Once we got the diazonium salt, now we can use Sandmeyer reaction, and we can give copper chloride CuCl HCl also. So it will easily converting from diazonium salt to chlorobenzene. Okay. The next question we are having acetaldehyde to propanol. Let's draw it first. Acetaldehyde CH3, C double bond O, H, and propanol is, this is propane, this is propan 2 all. So just the ketone will be converted into alcohol. So this is acetaldehyde, this is propanol. So what we have to do, we have to add the reducing agent only. So from aldehyde to alcohol, if we want to add any reducing agent, we can add lithium aluminium hydride. We can do that. So this can be the reducing agent reduction. Next it is asked, name two purine base. So as you know, for purine base, we are having two type of base in biomolecules, purine base and pyrimidine base. If adenine or adenine and guanine or guanine, okay. And where DNA RNA is, we can differentiate between DNA RNA. The major differentiation between DNA RNA can be done because by the bases also in DNA, whether the pyrimidine base is thymine But instead of thymine in RNA, the pyrimidine base is uracil. And the other difference is DNA means deoxy. At 2 position, the carbon is deoxygenated, deoxyribonucleic acid. Whether RNA is oxy means the carbon of 2 position is not deoxidized. So this is just ribonucleic acid. So these are the basic difference between DNA and RNA. Okay. Next, we are having arrange the following increasing order of their acid strength. Increasing order, whenever we are having any electron donating group, whenever we are having any electron donating group, then it will decreases the acidity of the benzoic acid, decreases acidity. But whenever we are having electron withdrawing group, electron withdrawing group, then it will increases the acidity, increases the acidity. So you see, this one is the electron withdrawing group because having the minus R effect. So here if I mark it as 3, if I mark it as 2, and here CH3 is present, which is electron donating group having plus I plus inductive effect. For this kind of knowledge, you have to follow my basic organic chemistry videos. I have given the link in the end button as well as in the description box. You can follow from that. There. So here the acidity order will be, the highest acidity will be for 3, then it will be for 2, then at the end it will be for 1. So this will be the acidity order. This one will be the last question for this video because it is becoming very long, lengthy. So I will publish the rest of the question in another video. So let's do that. What are the product formed when benzene diazonium chloride reacts with phenol in weak alkaline medium? So here the thing is, benzene diazonium chloride we are having. So this one is diazonium salt, and we are having phenol here. We are having phenol here. OH in the weak alkaline medium. So the medium is not much alkaline, is not much acidic. This one is weak alkaline medium. So here, as we know, in the benzene, OH will show the plus R effect, and the plus R effect will be highest at the para position, and the electron density will be highest at the para position. So through the para position, coupling reaction will happen. So here the answer will be formation of coupled product, or we can see coupling reaction here, and the product will be like this. So ultimately we will get something like that. Okay. So here the thing will be that coupled product we will get. So this will be the observation. So this much for this video. I hope the video was helpful for you. And if you need more this type of question, if you want to practice, then follow my channel. And if you have liked this video, then like it, of course. And if your friends are also preparing, then subscribe it. And don't forget to comment also if you're having any doubt or any question. More question I will upload in my more videos. And recently I'm thinking to give some videos about comparative exam, JEE mains, advanced NEET also. And if you know your friends doing preparation, then you can share my channel and subscribe it, like it, do share, and do comment also. And I will give that comparative exams video also, and this will be very very helpful, that I can tell you. So for this video, this much only, and thank you very much for watching.